Good morning, guys. Mr. Milton here. Today we're going to talk about overlapping triangle proof. Okay, at the end of this video, I want you to be able to identify shared sides and angles of overlapping triangles, to be able to redraw and label the two triangles from overlapping triangles, and to prove two overlapping triangles congruent. So overlapping triangles, if you look at the picture, notice how in each of the diagrams below there is at least one shared part between the two triangles. So just kind of ease ourselves in here, we're going to be able to identify the shared part. And that's just the part that's a part of two triangles. And so if you look at this first diagram, we can see triangle PRB, we can see triangle ARB. Let's move this up. Okay. So you can see those triangles. And so what is a part of both of those triangles? Okay, the thing that does not change is B, this angle B. So angle B is the shared part. Notice that even though we have, R in both of them and C in both of them, and here, this first triangle R is an angle. Sorry, too much stuff in the way. R is an angle, and C is not really anything. It's just a point on the side. Same here. So it's not really a shared side or angle, and that's what we're talking about. In our second set of triangles, we look at the shared parts. We see that we have LP, that side LP that doesn't change. LP is our shared part. And the third set of triangles, and actually for this one there's, depending on what you're looking at, we could be looking at these two triangles down here. Could be looking at these two triangles here. Okay, so depending on what we're looking at, we can see some different shared angles. So see angle D is shared between these two triangles, and then you see that between EAB and CAB, AB is shared. Okay. When you've identified the shared part, you have one congruent part of the two triangles because of the reflexive property. And that means that helps us out with our proof. And then you'll only need to prove two more congruent parts to prove the triangles are congruent. So let's go through a flow proof for the overlapping triangles. So they gave us that angle T is congruent to angle R and that PQ is congruent to PV. They marked that for us, and if you can see this right now, and they want us to prove that angle PQT is congruent to angle PVR. Okay, so this is kind of a hint that, hey, we're going to have to use CPCTC. Okay, but if you look at this, they tell us that PV is congruent to, or sorry, PQ is congruent to PV, and the markings are kind of not as clear because it's a part of a shared side. So let's go through it. That's what we're have to deal with. So angle T is congruent to angle R. We know that because it's given. They also told us that angle T was congruent to angle R. That's already marked for us. Okay. All right. And then they said that angle TPQ here is congruent to angle RPV. So notice, even though it has a different name, TPQ is talking about this angle, RPV is talking about the same angle. How can we tell it's congruent? Well, it's the same angle, it's reflexive. It's congruent to itself. Okay, remember that when we say itself, it doesn't have to be the same name, it's just we're referring to the same thing. Okay, and then they tell us that PQ is congruent to PV. Again, that's given. It's also given to us in the beginning, and it's marked here. Okay. All right. Now, we have three things that are congruent. So we know that at this point we might have enough to say that two triangles are congruent. All right. It can be very confusing to try to get to answer D. So it might be a good idea to redraw the triangles so that you're trying to prove them, or redraw the triangles that you're trying to prove congruent. Redraw. Okay, and I gave you some space to do that on the back. So we're going to do that and then we'll come back around. Okay. So what we're going to do, not only are we going to redraw these triangles, we're going to redraw and label them. And I wish I had enough space to put it on the same side, but I didn't. Okay, so we're going to redraw and label them. So if we, I always like to look at T, I always try to set it up the same way so I don't have to think about like it past. It makes labeling easier if I try to set it up the same way. Okay, so I have T, P, Q, and you guys can keep looking at that first side if that helps you with this redrawing, and just do this when we get to the back side, or when you get to the back side. Alright, so initially we said that PQ was congruent to PV, right? And it's a little bit easier to see now that we separate that triangle. We said that TPQ, angle TPQ, was congruent to angle RPV, and then we said that angle T was congruent to angle R. Okay, and so now we see it's a little bit easier to see from these two redrawn triangles why our two triangles are congruent. We have angle, angle, side, angle, angle, side, because our side is not included, so it's not angle, side, angle. And so it's a little easier to see angle, angle, side when we separate, when we've redrawn and separated our triangles, than if we're just looking at it as it is. So we have angle, angle, side. Okay, and like I said at the beginning, it kind of gives it away that we're trying to prove parts congruent. So I'm over that we're going to use CPCTC, which remember stands for corresponding parts of congruent triangles are congruent. So since we know that these two triangles are congruent, and angle PQT, this angle, is corresponding to angle PVR, then we know that those two angles have to be congruent as well. Okay, so the new part really is just being able to redraw and relabel the triangle in order to clarify for yourself. So not any real new information other than just looking at some overlapping triangles. Alright, let's go through these first two proofs together. If you want to challenge yourself, try the third one. Alright, so first proof, want us to prove that triangle QDA is congruent to triangle UAD. Okay, QDA, UAD. Sometimes it's helpful to look at it as overlapping, and then sometimes it's helpful to look at it as separate. So I'm going to draw this separate, the two triangles in question separate first, QDA, UAD. Okay. And then always think about what your plan is. What's your plan going to be to prove these congruent? Alright, I can see from the beginning that this is a shared side, so I'll probably use reflexive property. Once I do that, I have angles, side, angle, side. Okay, so pretty straightforward here. They gave us, first of all, through marking, that QD is congruent to UA. And that's given. They also gave us that angle QDA is congruent to angle UAD. Okay, and I had that marked for both of them. Given. And then, like we said just now, that this is a shared side. So I'm just going to say DA is congruent to, and I know I have this question a bunch, like, is it okay to say DA is congruent to DA, or because the congruent statement, do I have to say AD? It's better to say AD. I will not mark you wrong if you say DA is congruent to DA. But DA is congruent to AD because of the reflexive property. Okay, remember to use reflexive property. I have some people using given for that. That is not a given statement. If it was given, it would already be marked for us. Alright, and so we can see we have side, angle, side. So I can say, okay, these two triangles, triangle QDA is congruent to triangle UAD. And that's because of the reflexive, reflexive, I read it and I said it. Side, angle, side. Alright, let's try the next one. Alright, So this one's a little bit difficult in the sense that we don't necessarily know which triangle they're talking about first, because they're asking us to prove that CD is congruent to ED. And so that CP-CTC kind of leads us to know that we're probably going to use that because we're proving two parts. And so we got to find out which triangle is helpful for us to know. So we'll start with the givens. They told us that EB is congruent to CA, EB this diagonal, CA this diagonal. And so you can kind of see that it's kind of not very helpful in picture. So we have two options here. We could be talking about this triangle, these two triangles at the bottom here, EBA and CBA. Or we could be talking about the triangles DCA. Try to draw this out here, and DEB. Okay, and so I'm going to draw these out really quick. Alright, so they told us that AC was congruent to EB, or CA is congruent to EB. CA, EB, CA, EB. Alright, the next thing they told us is angle DAC, DAC is congruent to angle DBE, DBE. Okay, and so you see that we're marking in this triangle. So this triangle, even though we could have been talking about it, we're not. Okay, so now we need to see what's shared between these two triangles. Okay, we see that angle D is in both of these top two triangles, so that's a shared angle. And so we'll have angle, angle, side. We can prove those two triangles congruent, and then we can use CP-CTC. Okay, so let's do that. Kind of walk through what we're going to do in the proof. Makes it a lot easier to write the proof. Okay, so EB is congruent to CA, that's given. Number two, angle DAC is congruent to angle DBE, that's given. Alright, our third thing that we figured out that those two angles, angle CDE, yeah, am I saying that right? Nope. CDA is congruent to angle BDE. Again, we use the names that point to the angles in these two triangles, but it's still the reflexive property, even though we didn't name it the same thing both sides. Okay, it's the shared side, it's the reflexive property. And then finally, those two triangles, let's say ADC is congruent to triangle BDE by angle, angle, side. And so we wanted to initially prove that ED this side is congruent to CD this side. And so we can say that ED is congruent to CD, ED, CD by CP-CTC. Corresponding parts of congruent triangles are congruent. Okay. If you want to try 9, some difficulty there, try it out. I will upload a key, but you should hopefully see some strategies to solving proofs with overlapping triangles. See ya.